Okay, so far you had an overall perspective of the five schools of open science, and you had a slightly deeper look into the democratic and the pragmatic schools. Both are strongly connected and complementary because they are all about opening any type of product resulting from research activities. The first school is about the democracy of it, and the second focuses on all the good things scientists can do if they have access to more science. But now we're going to discuss the public school, which relates to the fact that science should be truly accessible to everyone. But what's the difference from the other two schools I've just mentioned? Well, we must think that it's all about going beyond access. And to explain what I mean by that, let me come back to the COVID example mentioned by Ted. So, uh, during the pandemic, Green Open Access, which includes scientists publishing their papers in preprint servers, has gained a lot of traction. Society needed science to respond fast, and scientists did just that. A lot was produced, and as discussed, some of the research made available was not yet reviewed, or even was not even ready to be out there. Of course, this type of situation has contributed to fake news and the misinterpretation of results. Everyone was thirsty for answers, and people without the necessary training to understand the available research, especially its limitations, would sometimes communicate imprecisions or alternative versions of the facts. And while we would all hear people mention they have done their own research, scientists would be frustrated because people just don't understand. But the solution to that is we need to be realistic. Not everyone has the time, the training, or the intention to ingest science. We dedicate years and years to be able to really understand value and even be critical about work conducted in our own fields. How could we expect that every citizen would be able to digest what's in a scientific paper? Just because it's open and free to read, it doesn't mean it's accessible. So that is the public school of open science. It's about more than access, it's about more than being free, it's about more than making science available to other scientists. The public school is about making science available to the public. That means the type of output that we expect from researchers is beyond the traditional journal paper or similar type of product designed to be inwards oriented, directed to the academic community. And how can you do that? One of the ways is all about diversifying. And I'm going to show you a real life example, a real life experience from Brazil that's totally in line with the concept of openness. You see, in Brazil, there's a national evaluation system organized around 49 research areas, or evaluation areas as we call them. These areas that you see here as honeycombs are arranged into three broad groups: exact, technological, and multidisciplinary sciences, life sciences, and humanities. Within each of these groups, we also have smaller groups: agricultural sciences, applied social sciences, biological sciences, and so on. What happened a few years ago was that a working group was created with representatives of these different groups, myself included as an evaluation officer of the Brazilian Agency for Support and Evaluation of Graduate Education. At the time, we worked on a proposal regarding products resulting from research that could be valued and valuable for each one of those 49 evaluation areas. Our proposal resulted in mapping 21 types of products that should be considered as research outputs. So, in this distribution of honeycombs, you see the number of areas stating that those specific products were deemed to be valuable in those disciplines, as listed in their evaluation criteria documents. From top left, we can see taxonomy, ontology, and thesaurus being relevant for three areas only. But when we look at the bottom right with bibliographic products, we see that the majority of the 49 areas decided this was important. And when you talk about bibliographic products here, we're not talking once again about papers or books or outputs like that. We're talking about blog posts, magazine articles, newspaper articles, and other types of bibliographic products. In the same way, we have technical reports that could include, for instance, policy briefs and other types of reports that are destined to a non-scientific audience. Then there's event organizing, software development, social technology, databases, collections, translations, and so many other things that you can explore. And the relevance of that is allowing different disciplines to decide what's valuable to them. So, on the one hand, we have the public school being about producing a multitude of possible products aimed at different audiences. There's another important side of that school which relates to involving citizens in the scientific process. You might have guessed already that we're talking about citizen science, which can be defined as scientific work undertaken by members of the general public, often in collaboration with or under the direction of professional scientists and scientific institutions. And that is the definition that made into the Oxford Dictionary back in 2014. But to talk more about that, we have an open science champion to bring us an interesting perspective. So I give you Sonja Grosberndt from NILU to enrich our discussion.
Hi, my name is Sonja Grosberndt. I'm scientist at NILU, the Norwegian Institute for Air Research. Welcome to this short video about the importance of citizen science from a researcher's perspective. Citizen science is a term that describes the involvement of the non-academic public in the process of scientific research. There are other terms in use, however, the term citizen science is amongst the most common ones in Europe, and I will stick to this term in this video as well. Citizen science volunteers can be engaged in different ways, from framing the research question, the development of tools and methods, to the data collection and analysis, the interpretation, but also in the dissemination and communication of results. There are two characteristics that distinguish citizen science from other forms of public participation. The first one is that the volunteers are actively involved in research, in partnership or collaboration with scientists or professionals. And the second one is a genuine outcome, such as new scientific knowledge, conservation actions, or policy change. Principles for citizen science have been described by ECSA, the European Citizen Science Association, and they can be found at their web pages for further readings. How does citizen science connect to open science? Citizen science can be both an aim and an enabler of open science. It presents the means for open, holistic, and participatory processes to create knowledge. Or, as it is also put, while open science opens the door of academia to the world, citizen science invites the world to experience science. And what makes citizen science so important for research? Well, the first aspect is the data collection. Citizen scientists can collect large amounts of data, often geographically widespread, that professional scientists don't have the capacity and resources to collect. Through citizen science, professionals can also obtain input on perspectives and issues that are relevant to their research from those that are actually concerned. This is, for instance, the case in research related to mental health or cultural heritage. Citizen science can enable transdisciplinary cooperation amongst researchers and contribute to responsible research and innovation and democratize science. It opens up for innovative ways of science communication by creating knowledge about scientific topics and studies, and by preparing deeper understanding of scientific results amongst the public. For instance, to prevent the spreading of fake news. It can also make science more accessible and more relevant for many. At NILU, we have almost 10 years experience with citizen science projects. And in this time, we have carried out many projects where we invited volunteers to measure air quality, either by building and or hosting an air quality sensor, or by providing information about their personal perception of air quality. We also had a number of school projects, focusing on education and awareness raising. Citizen science helped us to obtain air quality information from places that are not covered by official monitoring stations. We also use it as means to connect citizens with public administration, research, and private stakeholders. We discovered that new emerging low-cost sensor technologies offer new ways to engage with people, but we recommend that technology in general should only be a means, not the purpose for citizen science and public participation. From a scientific perspective, data collected through low-cost sensors are not always of good enough quality. But the air quality information we received through citizen science projects could indicate new pollution hotspots, and the large amounts of data collected could also help to support air quality models and could be used for machine learning. The large amounts of data require an adequate infrastructure for data collection, storage, quality control, and processing. We have this in place, and this offers new opportunities for further work. With regard to open science, this kind of infrastructure is also a means to make citizen science data available to others and enable reuse. We see that citizen science plays an important role in today's research activities as one main pillar of open science. And in this context, it is important for us to share our experience and learn from others. On a European level, this is done, amongst others, through networks like EXA. But also in Norway, we have the ambition to foster the concept of citizen science as part of open science. And we are now in the process of establishing a national citizen science network. This shows the importance of citizen science in Norway and the ambition to establish citizen science nationally as a recognized, promoted, and funded approach. With this, I thank you very much for your attention.
So, Sonia gave us a comprehensive overview of what citizen science is and some of its characteristics, applications, and even interesting examples in Norway. But I'd like to come back to some of the things she mentioned so we can look at the different ways citizen science can be an extension of knowledge-producing actors. For instance, citizen science can be about science motivated. And what I mean by that is that scientists can listen to citizens in order to set priorities, decide what's important or relevant to society, and so on. A good example of that is how the Dutch research agenda has been built with the participation of citizens in the priority setting. Another very common application is in help for science. As Sonia mentioned, citizens can, for instance, collect data that would be impossible for the scientists themselves to collect. An excellent example of that comes from Naturalis, a biodiversity center here in Leiden. At Naturalis, they have a series of citizen science projects, and one of them is quite interesting, called SnailSnap. Scientists pretty much noticed that there were color and pattern variations in the snail shells, and that those could be caused by temperature variation. So what they did was create an app so that thousands of people across the country could photograph snails in their own backyards, and then they would share those photos with GPS information so that this type of temperature change could be mapped across the country. And we also have the possibility of science together, where scientists and citizens bring their own expertise to collaborate on any sort of investigation that may be interesting for both. And a good example for that is the interaction between science and policy that can be even more efficient if it goes from evidence-based or evidence-inspired policy to a sort of jointly developed policy. And finally, there's the outreach aspect. And you're talking here about science communication, public engagement, science education, and other dimensions that actually make me think of something else very important to discuss. So, you're probably familiar with the concept of responsible research and innovation, a term that has been used by the European Commission for a little bit over a decade now to describe a framework to approach societal challenges with science. RRI has been basically shaped around 6 essential keys that are ethics, public engagement, open access, science education, gender equality, and governance, right? So, in the past couple of years, there has been movement inside the Commission that represents a sort of transition where RI is being translated or absorbed into the broader open science, citizen science idea. See, for example, this report published on December 21st, just a few months before we're recording this. This kind of materializes the transition because it talks about opening science up to society, and then it proposes 5 key changes that's exactly public engagement, science education, open access, gender equality, ethics and research integrity. And if you look at the report right smack in the middle, you have the higher education institution that relates to the concept of governance. So, pretty much the keys that we see until today in the RI initiatives are becoming a part of opening science up to society. And why is that important? Well, because we have discussed the term open science as an umbrella. And in the seminar, we're looking at the different facets through the 5 schools of thought. But the fact is that the open science umbrella is growing, and the 5 schools will soon need to be revised. So, with that, we close this brief introduction about the public school, and I leave you here with some application examples. From NWO, there's an interesting initiative to support citizen science, even with a specific funding module for that. And of course, there's the research agenda that I mentioned before. From the RCN side, we have a few exciting activities also related to citizen science, and one included here is the Pro-Ethics project, already investigating the ethical dimensions of citizens' involvement in science. There's also the Council's initiative to develop a national network for citizen science research, which is quite interesting. The links to those initiatives you'll find in the Knowledge platform or in the slides in case you had access to that. And with that, we continue to our next school of thought that relates very much to some of the aspects we have just discussed. I'm talking about the measurement school.